This entire lesson is about angles. Angles is something that we are all familiar with and we all use or see pretty much on an everyday basis in some way. Whether or not we think about it, we use it. And in this lesson we're going to get into the nitty-gritty of angles, learn about the different parts of an angle, learn the definition, and learn different types of angles as well. So first off, let's get our definition of an angle. So an angle is a shape formed by two rays that have the same endpoint. So we see here a picture of an angle. We have two rays, so notice we have a ray starting here at this point going up, and then we have a second ray starting at the same endpoint and going here to the right. So it is a shape with two rays that have the same endpoint, as we see here. So the two parts of an angle are what we call the side and the vertex. There are two sides, and the side is each ray of the angle. So right here, this ray would be one side, and then this other ray would be another side. And then where they meet, the common endpoint is what we call the vertex. And that is this point right here. Now we see here another picture of an angle, and we have labeled the vertex, and then we have labeled the other 2 points that make up the ray, and then we see this number 2 right here. And with angles, as with lines, line segments, and rays, there is a quick way to write or to name an angle. So when we are referring to different angles, the way that we can label it and name it is by using the 3 points as we see here. So this point A, this point B, which is the vertex, and then point C right here. So when we write an angle, the symbol for angle is right here. It looks just like an angle, but it looks kind of like an L. So I personally like to write it like this, with the angle symbol and then this little arc through it. Either is fine. It doesn't matter which one you use. The main thing is, though, the letters that you use. So we're going to use these 3 letters, A, B, and C, as we said, but it makes a difference the order in which you use them. Okay, the thing you have to remember is that the vertex, this point right here, point B, that letter must always be the middle letter. So for example, we could write this as angle ABC, where the vertex is here in the middle, and then point A and C are on either side of it. Or we can write it as angle CBA. So B is in the middle, and then C and A are on the other side. Okay, we can also use it with this angle notation if we would like, with the same letters being used. But what is not okay is if the vertex is not in the middle. So right here we see angle BAC. That is not okay because this, the way it's written, is assumed that A is the vertex. Well, we see here A is not the vertex. A is way up here. So that does not work. Or we cannot write this as angle CAB. Once again, the letter B is not in the center. So those are ways that are not okay to write this. But also there are 2 other ways you could write this. In this case, we can write this as angle B. So instead of writing all 3 letters, in this case we can write it with just the vertex, angle B. Or we can label the angles by putting numbers, as you see here, number inside of the angle to show which angle it is. So we can just say angle 2 if we would like as well. So make sure you know what's okay and what is not okay to use when labeling these. Here are 2 angles that are connected side by side, and we're going to work with labeling the different angles in this case. So there are different ways we said that we can write this, so a little practice here with this. We said we could use the number, so if we're looking at this angle right here, we can use the number 1 because that is the angle represented there. So we could write this as angle 1. Or we can write it using 3 letters. We can write it using the letters R, E, and S because those are the 3 letters that make up that angle. when we write it with the 3 letters, we need to put the vertex in the center. So E is the vertex. That needs to be in the center. So we could write it as RES or angle SER. Either is okay. In this case, though, we cannot just use one letter to represent this angle like we did in the last one, because if you just said angle E, well, we don't know which angle you're referring to, because there's actually 3 angles that could be represented. It could be angle RES, because E is the vertex, or we could also have angle SET, because E is also the vertex for that one. Or we could be referring to the big angle RET. We do not know just by using one letter in this case, because it's sharing a vertex. So we cannot write this one with the one letter angle E like we did with the first one. Okay, and you see over here on the right side here another example with the bottom angle. If you'd like to take a look at that, same idea as the first one. Now there are different types of angles that we see, and we see here 4 main types. So the first main type is what we call a right angle. A right angle creates a 90 degree. So we see here, this would be an example of a right angle. It forms 90 degrees. So that is a right angle. Acute would be something that is less than 90 degrees, so smaller than 90 degrees. So an angle like this right here. Obtuse, an obtuse angle we see right here, it's bigger than 90 degrees. Okay? And then a straight angle is just how it sounds. It's an angle that creates a straight line. So an angle like this would be a straight angle, and a straight angle has a measure of 180 degrees. Okay, and a way to remember this difference between acute and obtuse is acute, you can think something that is acute, you think of something tiny or small, and then obtuse sounds kind of like obese. So obese, you think of someone that's large. So obtuse is larger than 90, acute is smaller than 90. Just like in the last lesson, we talked about the segment addition postulate. We also have what's called the angle addition postulate. What the angle addition postulate is it says we can add 2 angles together, and that's going to equal the measure of the larger angle. So for example, if we look at here angle ABD, the measure of that angle is 32 degrees. So measure of ABD is 32 degrees. And we see the letter M out in front. This means measure. So if we were to measure the angle ABD with a protractor, we would get 32 degrees. Okay, measure of DBA. So DBA, this angle. I'm sorry, that should say angle DBC. So DBC, this angle, the measure of that angle is 45 degrees. Now, if you look at the large angle, angle ABC, well, the measure of that angle would simply be the addition of the 2 smaller angles. So if I add 32, this small angle, plus 45, this small angle, I'm going to get the measure of the large angle, which would be 77 degrees. And that is the angle addition postulate. It simply says we can add the 2 small angles to equal the larger angle. And then let's finish now with 3 more terms. And the next term we have is what's called congruent angles. As mentioned in a previous lesson, congruent means 2 objects that have the same size and the same shape. So it can be anything. We talked about the context of a line segment, but it can also be with angles. Congruent angles would be 2 angles that have the same size. Okay, they're both angles, so they have the same shape, the same size, meaning the angle measure is the same. So we see here this is 32 degrees. This also is 32 degrees, so therefore they would be congruent angles. Next we have what's called the adjacent angles. Adjacent, in our English vernacular, simply means next to. So adjacent angles are angles that are next to each other. More specifically, they must share a vertex and they must share a side. So we see here angle LMO. This angle would be adjacent to angle OMN. The angles that you see here that I just drew in red, these would not be adjacent because they do not share a vertex and they do not share a side. Yes, they're close to each other, but they're not technically adjacent because they're not sharing the vertex and side. And then lastly, we have what's called an angle bisector. So we see here we have this large angle right here. This angle is bisected by this ray right here. Okay? An angle bisector, by definition, is something that bisects or cuts the angle in half and creates two congruent angles. So we see here this ray creates two congruent angles, this one on the left and then this one on the right, that are both the same measure. They're both congruent, therefore this ray is what we call an angle bisector.